Okay, this is section 5.2. We're going to be looking at the addition rule and complements using probability. And so you can see our objectives. We're going to use the addition rule for disjoint events. And then we're going to use the general addition rule and then compute probabilities using what's called the complement. So first, before we get into the rules of computing some of these probabilities, we got to discuss this idea of what's a disjoint event. So two events are disjoint if they have no outcomes in common. So another name for disjoint events is mutually exclusive events. So sometimes you might hear me say disjoint, sometimes you might hear me say mutually exclusive. They are kind of interchangeable, so I apologize if I kind of overlap those. But so for example, what's the probability of tossing a coin and getting a heads and a tails? Would definitely be disjoint because there's no way you could do that. Or well, we'll go through some examples. Can't think of one off the top of my head, but if one happens, the other one cannot happen. So we're going to use what's called a Venn diagram to represent events as circles enclosed by a rectangle. So the circles are going to represent, so the rectangle represents our sample space, and each circle is going to represent an event. So for example, suppose we randomly selected chips from a bag. The chips are labeled 0 through 9. Okay, E represents the event choose a number less than or equal to 2. And F represents the event choose a number greater than or equal to 8. So, because they don't have any outcomes, E and F, they have no outcomes in common, they are disjoint. And here's how the Venn diagram would work. So this circle right here is event E. This is event F. And then the numbers that are still in our sample space but don't fall into event E or F, they just hang outside. They're still in the rectangle, so they're in the sample space, but they're not in E or F. Okay, and notice when two things are disjoint, they have nothing in common. So there's no overlap. So the probability that something is in E and F is impossible because there's no number that is in both E and F. So these would be disjoint or mutually exclusive. Okay. So we can calculate some probabilities. So what's the probability of event E? Okay, that's just the number in event E divided by the number in the sample space. So there are 3 outcomes in E divided by the 10 total numbers, 0 through 9. Okay, so that probability of event E is 0.3. Probability of F, well, in F there are 2 outcomes, 8 and 9, out of 10 possible in our sample space. So that'd be 2 out of 10 or 2/10, 0.2. Now, the probability of E or F, okay, that just means it's in E or it's in F. Doesn't matter. E or F it just has to meet one of the 2 criteria. So E or F, okay, there are 3 in E and 2 in F, so that would be a total of 5 out of 10. So the probability that we're in E or F is 0.5. Okay, so the probability of E or F is just simply the probability of E plus the probability of F. And this result occurs because of what we call the addition rule for disjoint events. Okay, and here is that addition rule for disjoint events. If 2 events, E and F, are disjoint or mutually exclusive events, then the probability of E or F is just the sum of the 2 probabilities because there's no overlap, so we can simply just add them together. Now, this addition rule for disjoint events can be extended to more than 2 disjoint events. So if you have the probability of E or F or G and so on and so forth, and all of these are mutually exclusive, then you just add each of the individual probabilities up. Okay, so that's when we're disjoint. There's no overlap. However, the general rule of addition, because there could be some things that happen or some circumstances where things are not disjoint. So what happens now? So suppose we again randomly select from bags of chips. Our labels again are 0 through 9, so we have 10 possible outcomes. E represents choose an odd number. F represents choose a number less than or equal to 4. Hopefully you can see there are going to be some odd numbers that are less than or equal to 4, so we are going to have some overlap, so that's why they're not disjoint. So E is all of our odds, 1, 3, 5, 7, 9. F is everything less than or equal to 4, so 0, 1, 2, 3, 4. So they've got a couple outcomes in common, 1 and 3, so they're definitely not disjoint. So when we're drawing our Venn diagram, notice that 1 and 3 are in this overlap. That means that 1 and 3 is contained in F. It is also contained in E. And then notice that there's only 2 numbers that don't occur in E or F, so those are just hanging outside here. They're still in our sample space, though. You can't forget those. Okay. So when we have this, so the probability of E, event E, is going to be there are 5 things in event E, so 5 out of 10. The probability of event F is going to be likewise 5 out of 10, because I count up 1, 2, 3, 4, 5. There are 5 different outcomes in event F. So then the general addition rule is the probability of E or F equals the probability of E, which is 5 out of 10, plus the probability of F, which is 5 over 10, minus the probability of something that is in both E and F. And notice we have 2 out of 10 outcomes. And if you think about it, this 1 and 3 gets double counted because we counted in E. It's 1, those are 2 of the 5 in E. They're also 2 of the 5 in F. So what happens, why we subtract this probability of E and F is because it gets double counted. And so when things are not disjoint, you have to subtract the probability of E and F, that overlap in our Venn diagram. So the probability of E or F is going to be 8 out of 10, or 0.8. And that's the general rule, this guy right here. Because notice, if things are disjoint, then the probability of E and F, that's going to be 0, because they have no overlap. So it just takes us right back to that disjoint rule. Okay. So again, here is your general rule for addition. And when we talk about addition, this is, when you think addition, you should be thinking OR in probability. So OR is addition, and is going to turn out to be multiplication. So you'll need to get those two kind of separated in your mind. So OR, addition, and multiplication when we get into more complicated AND scenarios. Okay, so let's look at an example here. So we got a probability experiment is conducted in which the sample space is 1 through 12. Event E are the numbers 2, 3, 4, 5, 6, 7, 8, and 7. Event F, and then G, and H. Now, assume that each outcome is equally likely. That's critical to have here. And we want to list the outcomes in F and G, and are F and G mutually exclusive or disjoint? Okay, so we want to know what is in F and G. So we are going to look for the overlap. So F has 5, 6, 7, 8, 9. G has 9, 10, 11, 12. So their overlap, the AND part, will just be the outcome 9. Okay, that's the only thing that they have in common. So are they disjoint or mutually exclusive? They are not, because they have one outcome in common. So it could be 1, it could be a billion, but if they have anything in common, they are not mutually exclusive. Okay. Then we want to list all of the outcomes in E or H on number 8. Okay, so let's look at E or H. So or means it just has to be in one or the other. Oops. So E or H is going to be the set, and H is 2, 3, 4. So 2, 3, 4. And then E has 2, 3, 4 as well, but 5, 6, and 7. So definitely not disjoint. So we want to know the probability of E or H. So that's the probability of E. Okay, and E has 1, 2, 3, 4, 6. So it's going to be the probability of E plus the probability of H, and then minus their overlap, probability of E and H. So in this case, the probability of E is going to be, there's 6 out of 12 in E, because again, remember our sample space is 1 through 12. Then plus the probability of H, there are 3 in H out of the 12. And then we have to minus the overlap. And what do they have in common? They have in common 2, 3, 4. So we have to subtract 3 out of 12 because we don't want to double count those. So this will be 6 twelfths plus 3 twelfths, which is 9 twelfths, minus 3 twelfths, so that's 6 twelfths or 1/2, 0.5. Okay, so this would be the probability of the event E or H. Okay, so again, when you're doing the addition rule, you have to make sure that you subtract off those things that they have in common when they are not disjoint. Okay. Okay, now let's look at one where we're just given some information and see if we can find out a few things. So we know that the probability in this one, probability of event E is 0.25, the probability of event F is 0.45, and we want to find P of E and F if we know that the probability of P of E or F is 0.6. So remember, probability of E or F is the probability of E plus the probability of F minus the probability of E and F. So we know the probability of E or F is 0.6, the probability of E is 0.25, and the probability of F is 0.45, but we don't know the probability of E and F. And now we just have an algebraic equation that we can solve here. So this will be 0.6 equals, if I add 0.25 and 0.45 together, that's 0.7 minus the probability of E and F. Okay, so then I'm going to subtract the 0.7 from both sides of my equation. I have to jump up over here. So then I would have negative 0.1 equals negative, don't forget that negative on there because we're subtracting probability of E and F. And then just multiply both sides by a negative and you'll get 0.1 equals the probability of E and F. So 10% or 0.1 is that probability. Okay, another one, we have the probability of F is 0.3, E or F is 0.65, probability of E and F is 0.15, I want to find the probability of E. So again, the probability of E or F equals the probability of E plus the probability of F minus the probability of E and F. So E or F is 0.65. Probability of E, we don't know. Plus the probability of F is 0.3. And then minus what they have in common, E and F. So then you'll do 0.65 equals the probability of E plus, when I combine 0.3 and 0.15, when I subtract those, I get 0.15. So then I'm going to subtract 0.15 from both sides of my equation. And this will give me 0.50 equals the probability of E.